Welcome to the CADWolf tutorial on documents. Documents are the backbone, heart, and soul of CADWolf and are where users solve and document equations. Everything else in CADWolf is designed to facilitate the use of documents. Workspaces store documents and other items, datasets store data to be used in documents, and part trees use documents to build large projects. This tutorial covers the basics of what a document is, how one is created and edited, and then we will discuss the various views available in a document. Documents are simply web pages that have been formatted to have an appearance similar to a word processor like Word or PDF. In fact, we use the phrase file in place of documents throughout this and other tutorials. These web pages also have code that lets them solve equations, make charts, and do a number of other things that we'll discuss later. All documents start with the phrase documents at the beginning of their URL. So what is the process for building a document? When you are editing a document, you will see a GUI on the left side of the screen with an option to enter an item. Clicking on that icon will add the item to the document. You see this process represented in the actions on the right side of the screen. Equations in documents are solved top to bottom, and when one equation is changed, all subsequent equations and charts update themselves. To add an item to a specific place in the document, simply click on any item in the document and then click on the GUI to add the item. The new item will be added below the currently selected item. Let's walk through the process of creating new documents and adding items to it. To create a new document, click on the icon in your workspace. When the new document appears, check out the document and then change its name to whatever you desire. Remember that the name of the file is part of the file's URL, so there are strict naming conventions. Basically, you are limited to the use of text, numbers, spaces, and dashes. Once the name has been changed, simply hit enter and the name will be saved. Then click on the icon to navigate to the file. Looking at the document, we can see the edit block on the side. When the user mouses over the block, it comes into focus and you can see that there are three sections. The first section provides a list of options that the user can click on to add a new item to the document. These items are text, headers, breaklines, equations, charts, tables, for loops, while loops, if-else statements, symbolic equations, images, and video. We do not discuss how to set up or edit these items in this tutorial, as there are separate tutorials for each item. The second section provides a place for the user to move an item. This can be done by clicking on the item you wish to move and then either entering the desired location or using the arrows to move the item up or down. The final section lets the user edit the item's width and margins. When the item is first added to the document, its width is equal to the width of the document. By clicking on an item and then editing its properties, the user can place multiple items on the same line in the document. Let's build a simple document. Clicking on the icon at the top, the user can add an item to the beginning of the document and set it after a current item. We click on the header line to add a header block to the file and then edit the header and hit enter. Next, we add a text block to the document and paste in some text. After this, we add an equation to the document. Note that the default text is present and you can edit it by double-clicking on it. We then enter the text needed to create a vector named x going from 0 to 6 in steps of 0.025 and hit enter. After that, we add a second vector to the document named y and set the value to a combination of trig functions. There is a separate tutorial on equations, but you can see the basics that were demonstrated here. First, the name of the variable is entered, followed by an equal sign, and then the equation. There are items like the trig functions and the vector function that you saw here that we call built-in functions. The equation tutorial provides a great deal of detail about editing and using equations. After the equation, a chart is added to the document. The chart type is selected, and the x and y data is set for the x and y axes. Notice that when we change an equation, the following equations and the chart update automatically. Just as with equations, there are tutorials for charts, and the details of editing a chart's content are not part of this tutorial. What we do show is that when the initial equation is changed, the subsequent equation and chart changes as well. As stated, the third section of the edit bar lets the user change the width of each item as well as the margins around each item. To demonstrate this, we click on the first equation and then enter 400 pixels as its width. Repeating this with the next equation, we can see that as the width is changed, the equation moves up in the document. The reason for this is that the width of the document is 825 pixels. If two or more items combine to be less than that width, then they will stack up next to each other until the width is full. If an item would make the width too much, it is pushed beneath the current item. Any item that can have its width changed, however, if the width of the item is more than the given width, it will overflow into the surrounding area. Clicking on the text block, we see that its position is 1. The reason for this is that the count starts at 0, and the header occupies that position. Changing the position to 3 moves the text block to that location. Note that every item has a blue X in the upper right hand corner. Clicking on this X will remove that item from the document. Most items have a blue sprocket as well. Clicking on that sprocket will open a dialog box on the right hand side that users can use to alter certain properties. This is discussed in the tutorials for each item type. So we've covered what a document is and how to add an item to the document. Now let's look at the various views available to the user in the left-hand bar and discuss how those items are used with respect to the document. The sidebar for the document has 12 different views. These views can be broken down into 4 different categories: the general views, the views that help bring data into the document, the views holding the numerical constants, and the views relating to the use of files as functions. We'll look at each type of these views independently. Let's start with the general views. These views include the worksheet, the table of contents, the properties views, the bibliography, and the bug reporting view. The worksheet is the name of the main view where the user adds items to the document, solves equations, and all the other things we've already discussed. All of the other views are designed as helpers for the worksheet. Note that the document you are looking at is mostly text and headers, and that the headers have various levels ranging from 1 to 4. The table of contents view displays the headers in their proper orientation. This helps viewers see the organization of the document, and clicking on any of the headers in the table of contents will change the worksheet to display only that section. As you see here, the permissions section is selected, and only that section is then shown in the worksheet. This helps the user more easily find information and helps the browser use less memory. The full document view can be restored at any time, as you see here. The File Properties view displays a number of general properties and gives the opportunity for users to edit some of those. The first 2 entries in the view let the user edit the title and subtitle for the document. This is not the same as the document name, but rather the title and subtitle that appear at the top of the page when it's loaded. After this, the user is shown when the document was created and last saved, as well as who has the document checked out. If the document is not checked out and the user has edit permission, then an option is given here to check out the document. Next, an option is given to view the table of contents as the default view. By doing this, large documents will not have to be loaded all at once during the initial load. The user is then shown the permissions available and offered a chance to see and possibly edit the description of the document. It is this description that appears in the info section of the workspace containing the document when the info item is selected. CADWolf lets users add references for an item. When that is done, a number is shown below the corner of the item, indicating which reference applies to it. The bibliography view shows the user all of the references in the document. The tutorials for images, equations, and other items explain how to add references to them. The bug report view lets the user report a bug to CADWolf. All the user needs to do is enter the text and press the button to submit the bug. Now let's talk about the views that let you bring data in from other places into this document. There are 2 sources of data that can be utilized in any document. The first source is an equation in another document, and the second is a dataset. There is a view to bring data from each of those sources. The inputs view lets the user bring a variable from another document into this document. Here, you see a file with a list of inputs already brought into this document. To add an input, the user clicks on the button to add an input and a dialog appears. In the top line, the user enters the workspace holding the file the user wants to draw from. When that is done, all the files in the workspace are shown. Double-clicking on the desired file in the left window will bring up all the variables in the document in the right window. Clicking on the desired variable will bring it into this document. The variable is then accessed using the name of the variable in an equation. The Datasets view lets the user bring data in from a dataset. This is done by clicking on the appropriate button, and in the line that appears, the user enters the URL of the desired dataset. The user then gives the dataset a name. It is this name that is used as a variable in this document. By doing this, the same dataset can be brought into multiple documents with a unique name in each document. Here we see that the dataset that was named tensile is used in an equation. CADWOLF documents have a number of predefined constants that can be used in any equation. Equations also recognize and track units. There is a view that simply shows the user those constants, and another view that shows the user all of the units they can use. We'll talk about each of those briefly. When we say that CADWOLF equations recognize and track units, what we mean is that users can add unit abbreviations like mm for millimeters to a number, and CADWOLF will understand that this is a length given in millimeters. You can add a length of millimeters to a length of inches in CADWOLF, and it will return the proper number. The unit conversion view shows the various units that CADWOLF recognizes. Looking at the view, you see a list of quantities such as length or force. Clicking on any of these quantities will display what units are recognized as that quantity. For example, the length quantity will recognize mm for millimeters, in for inches, au for astronomical units, and a number of other things. The constants view shows all of the special items that are recognized within the equations and what the user must enter to use those items. These items include things like pi and Avogadro's number. Although a CADWOLF document has text, charts, and other things, each document is essentially a program that solves equations from top to bottom. As such, any document can be pulled into another document and used as a separate function. We call this using a file as a function. Prior to using the file as a function, each document must be set up to establish which values are the inputs and which are the outputs. The file will pull in only the equations and not the charts or text. For example, let's say you created a CADWOLF file that had two constants a and b. In this file, the variable c was created by adding the two numbers together, and the variable d was created by subtracting the two. A and b could be established as inputs, and c and d would be established as outputs. After this, the user could call the function from another document where it was given the name mathme. This function would then take in two numbers and return two results, the sum and the difference. Failure to set an input results in the use of the constants in the original document being used. There are three views related to using files as functions. The first view is where the user establishes the inputs and outputs for the current document. The second view is where the user sets up the files, which will be used as functions within this document. The third view displays the files used as functions within the current document. Let's look at a file that has already been set up to run as a function. This file has three equations that simply set the values of a, b, and c. It then calculates the two roots of a quadratic equation with those three variables as the coefficients. Looking at the file as a function view, we can see that the name for this function is quadeq for quadratic equation, and that the a, b, and c are set as inputs, and the two roots of y1 and y2 are set as the outputs. To add an equation as input or output, the user simply clicks on the appropriate button and then selects the desired variable. Moving over to a separate file, we go to the defined functions view. You can see that we have added the quadratic equation file to be used as a function in this document. This was done by simply clicking on the button to add a new function and then entering the URL of the document that we wanted to use as a function. Looking back at the worksheet, you can see that the function is called with new numbers and that the two results were given. Going now to the imported functions view, we can see that the function that we pulled in is listed as the one that was used. This view just gives us a better idea of what files were used as function in this document, as it is a listing of the files that were actually used and not just the ones that were available. Well, we've talked about what a document is and how items are added to the document. We encourage you to view the tutorials on equations and other items to get a better understanding of how each item works. If you want to stay up with everything that's going on in CADWOLF, follow us on Facebook and Twitter.